Hello students, today we will take up the chapter applications of trigonometry. Basically in this chapter we will be studying about how trigonometry has its applications in our everyday life. Okay, like finding the height of the building, finding the height of the tower, finding the width of the river and so on. Okay. But before, let's say I have written up a question. Before we start this question, let us understand two things here. One is the angle of elevation. Let's say that this is a tower, right? And this tower is being observed from this point, right? From this point. The top of the tower is being observed from this point, right? This is the horizontal. This line is the horizontal, right? So when this top of the tower is being observed from this point, at this point an angle is made. I have marked this angle as theta. This angle is made. This angle we call it as angle of elevation, right? This is called angle of elevation. This is one term. And the second is, let's say that you are at the top of the tower, right? And you are here, let's say, let me mark it as ABC. You are here at the top of the tower and you observe this point, right? Point C, you observe this point C in the downward direction, right? This point C is here, let's say, on the ground. So from this point A, when you observe this point C, you are looking downwards, right? So let us draw one horizontal here. This is the horizontal. So the angle which the line of vision, right, or see, you can see this is the line in which you can see this point C. This, the angle between this line and this horizontal, will take it as theta. Okay. So this theta is called angle of depression, right? It's called angle of depression. But one thing here, this angle and this angle both will always be equal to each other. Let me mark this as theta 1 and theta 2. See, because these two lines, they are parallel, right? This is horizontal, this is also the horizontal. So these two lines, they are parallel. So, oh sorry, I'll mark this theta 2. So when these two lines are parallel, then theta 1 is equal to theta 2. They are alternate interior angles, right? So these are the two new terms to be used in this chapter, right? Angle of elevation, when you are viewing the top of anything from the point which is below, right? So from this point we are observing the top of this tower. Let's say this is the tower. Let us mark this as P, Q and R. Do not get confused with theta and Q. This is Q and this is theta. Okay. So you are observing this point P from the point R, which is in the lower level. So when you are observing in the upward direction, the angle which the eye makes with the horizontal, that's called as angle of elevation. Whereas when you are looking from top and below, right, then the angle which is formed between the horizontal and the line of vision, that is known as angle of depression. Now this angle of depression is equal to this angle. I have marked here theta 1 is equal to theta 2 because they form alternate interior angles. And these alternate interior angles are always equal to each other. Right? Now, I have written this question. The angle of elevation of the top of a tower from a point on the ground. See, just try to understand this. From a point on the ground, and it's saying the angle of elevation of the top. The angle of elevation of the top from where? From the point. Where is the point? On the ground. Right? Top of what? The top of a tower. Here it's a tower. So there is a tower here, and from the point on the ground, right? The angle of elevation to the top of the tower, right? The angle of elevation of the top of a tower from a point on the ground. This is the point on the ground. Let me mark this as A, B, C. The tower is perpendicular to the ground. Okay. So from this point C, the angle of elevation of the top of the tower, which is 30 meter away from the foot of the tower, is 30 degree. Right? Again, try to understand this. A point on the ground which is 30 meter away from the foot of the tower. See, 30 meter away. This point C is 30 meter away from the foot of the tower. And from this point, the angle of elevation of the tower is 30 degree. This is 30 degree. Now what we need to find here is the height of the tower, that is AB. Right? We need to find the height of the tower AB. Right? Now in this triangle ABC, C is the theta, that is 30 degree, which we need, for which we need to use the value 30 degree. C is theta, 30 degree, right? And the base is given to us, right? We have already discussed in the previous chapter, opposite to this theta is always the perpendicular, right? And this is the base, right? So the trigonometric ratio which relates perpendicular and base is tan theta and cot theta, right? So we can use either of the two. So let us use tan theta, right? So in triangle ABC, we have tan theta is perpendicular by base. If you remember, turns permanently black, right? So tan theta is perpendicular by base. So tan theta is 30 degree. So this is tan 30 degree is equal to AB divided by BC, right? The perpendicular is what? AB, and the base is BC. The value of tan 30 degree, if you remember in the previous classes I have explained how to derive the values in the standard trigonometric table. If you remember, the value of tan 30 degree is 1 by root over 3, AB is h and BC is 30, right? So now when we cross multiply, this becomes 30 divided by root over 3 is h, or h is equal to 30 by root over 3. Now the denominator here is an irrational number. So what we need to do is we'll rationalize the denominator, right? We'll multiply both the numerator and denominator by root over 3. Now the question here is why we need to multiply with root over 3. So the first thing, root over 3 into root over 3 is equal to 3. And what is 3? 3 is a rational number, right? Now the second question which can come to your mind is, why only we are not multiplying the denominator by 3, root 3, sorry. Why we are multiplying the numerator also by root over 3? There is no need to multiply the numerator if we want to rationalize the denominator, right? But now, see, I'll take one example first. Let's say we have 5 upon 6, okay? And if I multiply this 5 upon 6 by 3 and 3, I will get 15 upon 18. Now 15 upon 18 is actually an equivalent fraction of 5 upon 6. That means we are multiplying both numerator and denominator by 3 upon 3. Right? So basically what we are doing here is we are multiplying this numerator and denominator, this fraction you can say 5 upon 6 by 1. Why 1? Because this will basically divide 3 into 1, 3 into 1. And if you reduce this part also, right? Now you see here 15 upon 18. If you reduce it, you get 3 into 5 and 3 into 6. We are getting here 5 upon 6. It's the same thing. Only the thing what we are doing is we are finding the equivalent fraction. Now here if you apply the same knowledge, when we are multiplying both numerator and denominator by root over 3, that means this root over 3 and root over 3 will divide, and what is left? 1. So that means we are actually multiplying this h is equal to 30 by root over 3 by 1. Right? So, we cannot change the value of the fraction. If you are multiplying the numerator by one factor, the denominator also needs to be multiplied by the same factor, because this way we will be finding the equivalent fraction, right? Equivalent fraction. So, this h is equal to 30 into root over 3 is 30 root over 3, and root over 3 into root over 3 is 3. So 3 into 1 is 3 and 3 into 10 is 30. So height is equal to 10 root over 3. So height of the tower we got 10 root over 3 meters. Now let's say in exam you are asked to find the value in decimals, right? So you can remember one thing, you can even find the square root of root 3. Otherwise you can remember it like this, root over 3 is 1.732 and root over 2 is 1.414. Right? You can remember these values. Okay? So we can apply the value of root over 3 here. This will be h is equal to 10 into 1.732, which is 17.32 meters. So let me write it here. Therefore, height of the tower is 17.32 meters. 17.32 meters. Right? Okay, so we have taken another question. From a point on the ground, the angles, see here it's in angles, there are two angles or maybe more than two angles. Let me read the entire question. The angles of elevation of the bottom and the top, that means two angles, right? The angle of elevations of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building. Where is the transmission tower? The transmission tower is at the top, right? The transmission tower is fixed at the top of a 20-meter high building. Okay, the transmission tower is fixed at the top of the 20-meter high building. So first let's say we'll make this building, this is A, this is B. This is the building which is 20-meter high, right? And at the top of this building there is a transmission tower. Let us mark this point as C. This is the transmission tower, right? And this is the building. Okay. Now it's saying from a point on the ground, the angles of elevation of the bottom and the top of the transmission tower. Now there is a point on the ground, right? So let's say this is the point on the ground. Let us mark this point as T. The angles of elevation of what? First it's saying bottom and then it's saying top. Remember, the angles of elevation of the bottom and the top of the tower, right, is how much? 45 and 60 degree respectively. That means for the angle of elevation from the bottom of the tower is 45 degree, and the angle of elevation of the top of the tower is 60 degree. This is 90 degree, right? Now what we need to find is the height of the tower, right? So what is the height of the tower? Height of the tower is AC, right? Once again I repeat you the question. AB is the building which is 20-meter high. AC is the transmission tower which is fixed on top of the building. There is a point on the ground. From this point, the angle of elevation to the bottom of the tower is 45. An angle of elevation to the top of the tower, now it will increase, it is 60 degree. What we need to find is the height of the transmission tower. So I have taken the height of the transmission tower to be h. Okay. Now look at the solution. Here, first we need to analyze. There are two right angled triangles, A, B, D. This is one right angled triangle, C, B, D. This is another right angled triangle. Okay, so we'll consider one by one and say one more thing. In both the right triangles ABD and CBD, BD is common, the base is common, right? So what we'll take, the first triangle we'll take is ABD. In triangle ABD, we have again tan theta is perpendicular by base. Tan 45 degree is equal to AB divided by BD, right? Tan 45 degree is AB divided by BD, right? So tan 45 degree, the value is 1, AB is 20 and BD we don't know. So if we cross multiply, we get BD is equal to 20 meters, right? So now we got the value of BD. Now this value of BD we can use in triangle CBD, right? So next triangle which we will consider is in triangle CBD. Tan, I will not write this part again and again, I will directly write tan 60 degree is CB by BD. CB is perpendicular, BD is the base. This is CB divided by BD. This is root over 3. Now what is this CB? It is H plus 20. I'll write here H plus 20. And BD we already got here 20. Right? Now what we have to find here is the value of H. So again, if you cross multiply, this is 20 root over 3 is H plus 20. Right? We'll take 20 to the left hand side. This is 20 root over 3 minus 20 is H. So here, if we take out 20 as common, then what is left? Root over 3 minus 1. Right? Or we can write H is equal to 20 into root over 3 minus 1. See, either you can leave the answer up to here, or as I told you in the beginning, we can put the value of root over 3. So this becomes 20 root 3 is 1.732 minus 1. Okay. So this is 20 into 0.732, right? 20 into 0.732 after subtracting 1 from 1.732, you get 0.732. Now 2 into 2 is 4, 2 into 3 is 6, 2 into 7 is 14. Right? And the decimal which you want is there are 3 places of after decimal there is 3 places. So 1 place will shift. So this will become 14.64 meter. Right? 14.64 meter. If you multiply, you will get this 14.64 meter. Therefore, height of transmission tower is 14.64 meters, right? So we'll do this much for today. We'll take up some more questions in the next class.